Now that we've discussed address classes in IPv4, we're going to continue the discussion looking at special addresses such as the local broadcast address, loopback addresses, and other special addresses that you'll encounter in IPv4. We'll also look at network masks and CIDR, or classless interdomain routing, and we'll see how that affects the network and host portion of addresses in IPv4. So now let's look at some of the special addresses that you'll encounter in your networking career. The first one is directed broadcast address. A directed broadcast address is used by hosts to send data to all devices on the specific subnet or specific network. In direct broadcast addresses, the entire host portion of the address is populated with binary ones. So as an example, if we have a network of 172.31.0.0, the directed broadcast address is 172.31.255.255. Notice, because this is a Class B address, the first two octets denotes network, and the last two octets denotes host portion of the address. So the host portion is filled with binary ones. 255 in decimal equates to 8 binary ones. So the host portion is therefore populated with binary ones in both the third and fourth octet. So the address now becomes 172.31.255.255. Routers can be configured to route directed broadcasts. But by default, directed broadcasts are not routed from one physical interface to another physical interface or from one VLAN to another VLAN. There are hacking utilities that you can download and use to launch denial of service attacks or DOS attacks by using directed broadcasts. And thus, for security reasons, it's recommended that the forwarding of directed broadcasts be disabled. This is the default on modern versions of the Cisco iOS. So routers and switches will not forward directed broadcasts from one VLAN to another or route them from one interface to another interface. So here's a sample network. Notice this device, 172.31.0.1, is on network 172.31.0.0. 172 is a Class B network. So the network portion of the address is 172.31 and the host portion of the address is 0.0. This device is sending a directed broadcast to 172.31.255.255 using a hacking tool such as Smurf as an example. In other words, it's sending a broadcast to this subnet 172.31.0.0. Now, a router or switch configured to forward directed broadcasts will forward that directed broadcast to network 172.31.0.0, and all devices on that subnet, including this device 172.31.0.1, will receive that broadcast. So all hosts on that segment will receive the directed broadcast, will accept it. So in other words, the network interface cards will accept the broadcast and forward it to higher layer protocols for processing. The CPUs of every device will be interrupted to process the directed broadcast. Now normally, attackers would send the directed broadcast from the device that they want to attack. In other words, they may be using a different IP address, for example 172.16.0.10. But if they wanted to attack this device 172.16.0.1, they would send directed broadcasts to the subnet 172.31.0.0. In other words, they would launch lots of traffic with a source IP address of 172.16.0.1 to destination 172.31.255.255. All devices on this subnet would then reply back to the source address 172.16.0.1, causing a denial of service attack on that device. So a hacker is getting legitimate hosts on the network to cause a denial of service attack on another host on the network. Now, once again, directed broadcasts are not permitted by Cisco devices these days to prevent these kind of attacks using applications such as Smurf. Smurf is an example of an application that allows you to launch denial of service attacks using directed broadcasts. That's not as common today because routers and switches drop directed broadcast traffic by default.